Welcome to this joint production of the Colour Society of Australia and the AIC Study Group on Arts and Design. And we're very delighted to have João Durão with us, who is the chair of the Study Group on Arts and Design, and also the person that we owe International Colour Day to, the person who proposed the idea. So it's really fitting that we have her here today on what is our joint celebration of International Colour Day. So I'll ask you, Maria, if you'd like to say some words to introduce our event.
Thank you. Welcome all to the International Colour Day Forum. I would like to thank David Briggs for organizing this forum, and to thank the three painting conservators, Simon Ives, Marieke Gerken and Rika Pause, for agreeing to participate in this event. This is an International Colour Day event that is held together with the AIC Study Group, as David Briggs has already said. And it's the first of the new series of online forums on art and design topics. And both of us co-chair this study group in arts and design. And we plan to organize 3 more forums this year. Today's one has this particularity of coinciding with International Colour Day that is celebrated on the 21st of March worldwide. This ICD was actually launched on in 2009, although it was presented in 2008 at the General Assembly of the International Colour Association Congress. And soon you will be able to find the book that celebrates the existence of all the celebrations and whatever happened, and the fluency, and how it the whole process of establishment of the International Colour Day at the AIC online platform. The book is called International Colour Day, A Decade and Beyond, and it's edited by Durão, Kaivan, Schoing, and Bergström. And now I'm going to give the floor back to Dr. David Briggs. Thank you very much.
Thank you very much indeed, Maria João, for that introduction. Before we begin, I'd like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of the land I'm speaking from, and to pay my respects to their elders past and present. On behalf of the Colour Society of Australia, I'd like to mention that we are a 100% volunteer-run, not-for-profit organisation, and we welcome all to our events and membership. This event continues a series of webinars organised by the New South Wales Division since 2020. Our membership year runs from July to June, so if you'd like to support us, please consider joining as a member in the coming membership year. In any case, keep an eye out for on our website and on our Facebook, Instagram and LinkedIn accounts for our events through the year, and including our hybrid national conference in Sydney on the October 31st to November 2nd. We have a nearly full house of just under 100 registrants, which is great. They're from all around the world, so we're asking everyone to stay muted during the presentations, but if you have questions, please submit them to the chat, and we'll get to as many as we can in the discussion period at the end. Our first speaker, Simon Ives, graduated from the University of Northumbria at Newcastle with a BA in Fine Art Painting and an MA in Fine Art Conservation. He also has an MA in Painting from the College of Fine Arts in Sydney and is completing an MA in Fine Art Education. He's worked as a painting conservator at the Tate Gallery in London and the National Gallery in Canberra, and is now at the Art Gallery of New South Wales. Today, Simon presents the results of a paper he published with Paula Dredge and Gerard Austin and Daryl Howard in the Burlington magazine as its cover story in January 2023. So over to you, Simon. If you'd like to share your screen.
Okay. Can you hear me?
I can hear you.
Great.
Beautiful.
Okay.
Oh.
Well, it's a good crowding, so welcome to everyone all around the world. And the next two speakers are from the other side of the world. I've just come back from Bondi Beach when the sun's going down, and then we'll go to the other side of the world to talk with Marieke and Rika. And I can't wait for their presentations too, so I won't detain you too long, hopefully. But I think I've got half an hour on the outside. So I'll start my clock. And this paper was published in the Burlington magazine a couple of years ago now, actually. Paula Dredge was the lead author. It's been a while since she's been head of painting conservation. She's now in teaching at Melbourne University on the conservation course there. The project was many years in the making, actually, and it was based around a painting that was in our collection of Cosimo de' Medici, a portrait of Cosimo, who was Duke of Florence at the time it was painted, which is 1545. There's the team. We've got, if I can just get rid of these, sorry. And Gerard on the right, myself in the middle, and Paula's on the left, and Duke Cosimo on the table, face up, and on the right is the magazine article that came out. We're very proud to have it published in the Burlington as a cover story. The other author was Daryl Howard, who was the particle accelerator operator, a genius in particle physics and all the rest of it. So it's quite a disparate group. I'm actually a painter, but in my background, and this technology, which we're going to be talking about, is an X-ray technique which enables you to identify pigments by identifying the element which is characteristic of that element. So for example, lead white is lead carbonate, and it's based around lead. So if you find lead and it's white, there's a good chance that's lead white. There's complications. So if there's a pigment called lead tin yellow, you'll also find lead. But if you then move to the tin and you see the same pigment there, it's likely to be lead tin yellow. You used an XRF gun to do a point shoot where you could identify all the elements, but only at one particular point. And what we were able to do with the help of a particle accelerator, which I'll show you a picture of, which is very, very large, was actually do that XRF point, but then do multiple points. So you shoot in one spot, then you move 20 microns to the right, do another shot, 20 microns to the right, do another shot, and go backwards and forwards all the way across the painting at very high resolution, and put all those things together, and you get a map. So that was really a breakthrough, because it meant that you could see all these analysis of the pigments elements as maps, which corresponded to the painting you're looking at. So it made it much easier to interpret what you have. The next stage in the technology was to then put reduce the scale of the machine that you're using from something the size of 8 football fields to something you can fit in a box and put on a plane, which is what Marieke flies around the world using. This is sort of the fifth beetle in our group. This is Robert Simon. On the right, you can see Robert in front of our painting, Cosimo. That was when it went to Washington. Sorry, went to New York, I think. And Robert Simon standing in front of it there. On the left, he's standing in front of the Salvator Mundi, which is the Leonardo da Vinci painting that was famously discovered. And it was recently, and it was Robert Simon who discovered that painting. It was heavily overpainted, and he recognized from the edges, from the hand that really hadn't been overpainted, that there was something very interesting underneath, and the painting was restored, and sure enough, there was a painting by Leonardo da Vinci underneath, which is an incredible discovery. He published a research project that he had done into the painting that ended up at the Art Gallery, New South Wales, subsequently, this painting of Duke Cosimo de' Medici in armour, painted by Bronzino. It's on wood panel. The wood panel is poplar, which you can see on the right, and which is the normal wooden support that you would paint on in Italy at that time. In Northern Europe, it tended to be oak. So what Robert Simon was doing was trying to work out, there's a whole series of paintings by Bronzino and his workshop of this image. And there were sort of 20 or 30 of them. And he was trying to put together a chronology, which was the first one, which ones were painted by his hand, i.e. an autograph, what's called an autograph work, and which ones were workshop copies. Also, which was the first one, which was the first one of the entire series, and that all the others were based on, but also which was the first in these different sizes. So we've got this painting here, he proposed was the autograph work, it's in the Uffizi Gallery in Florence, and it's what's called a half length on the left. And you can see that our painting is here, and it's what's called a 3/4 length. So it's an extended version, includes the hips, and also includes on the right-hand side, you can see more clearly in this one, the helmet put on a truncated tree, which is included because it's the laurel tree, which was the insignia of the Medici family. And it has this side branch here coming out, which is hard to see in this image. But it was indicating that Duke Cosimo was a genuine side branch of the original Medici family tree. So it's authenticating him as a genuine member of the Medici dynasty, but a side branch. So that was a very important piece of iconography to include. So the painting went, Robert Simon thought, from this painting, the half length, up to this painting, the 3/4 length. And a bit of just a bit of historical context. The reason Bronzino was asked to put this image together and to include this important iconography was because at the time, the Medici family had been in exile, and there had been a republic in Florence. And in 1530, the republic was brought to an end by a siege by Charles V, who was the most powerful, figure around at the time, the Spanish Empire and the Holy Roman Emperor. And anyone who was ruling Florence was really ruling at his behest. So Cosimo was installed in 1537, a few years after the siege of Florence, which destroyed the Republic, which had been around for a few years. So 1527 to 1530, you've got the Republic in Florence. Michelangelo is actually part of that, interestingly. Here is one of his drawings for the barricades that that were erected to try and keep Charles V out and keep the Republic alive, and ultimately failed. There was a huge siege. I think a third of the population starved. Michelangelo went into hiding underneath the church in San Lorenzo, and just recently this church has actually been, this basement has been opened, and it's actually got Michelangelo's drawings all over the wall, which is incredible. He was in hiding under there to try and save his life, really, while the Charles V came in and the Medici family were reinstalled. So they needed Cosimo to look like a tough guy, like his father. That's him in the center, Bandinero, and here's Charles V on the right. So the portrait of Cosimo on the left here is really emulating Charles V and saying that I'm your guy. And I defer to you, because whereas Charles has a drawn sword, Cosimo is in a more passive sort of position with no weapon and with his hand resting on a helmet, which is removed. So that was the iconography that was going on. Then there was the question of which one came first, and our painting is on the left here is slightly larger, obviously, than the half length that's in the Uffizi. So it would make logical sense if ours was the first and then it was cut down, and there are actually some score marks on our panel, and that would be the one on the right would be the subsequent painting. But there was a reason why Robert Simon thought it was the other way around, and one of them was the discovery of pentimenti on the Uffizi panel, the panel which is now in the Uffizi on the right. And Bronzino is very well known for repainting a lot of his work. So I'll just show a couple of examples. So on the left is the allegory with Venus and Cupid that Bronzino painted in 1545. On the right's an X-ray, and it shows painting work that's underneath, which has been traced off here, and that's the drawing that you see in the center. And you can see a lot of changes going on Bronzino, even though his paintings, when they're finished, look like they've been done in one go and there's no modifications at all. Actually, when you X-ray them, a lot of the time you find, here's another one, underneath a different conception completely, which is transformed in the process of him working up his final works, to the point where actually it drove Cosimo mad, because who was his patron, Bronzino's patron, because he'd ask for a copy to be made and it would come completely different. And this is a quote from Bronzino writing to his one of the administrators in the Cosimo's regime, and he said that His Excellency had told him, I want it exactly as the other and I do not want it more beautiful. So what he's saying is that Bronzino would always say, but Majesty, I can do it more beautiful. And Cosimo's obviously saying, no, I don't want you to do it more beautiful. Just make it exactly the same as the one that we've got. That's interesting because under our painting, Robert Simon had discovered, this is from an X-ray in 1987, that there was something going on underneath our painting. You can see faintly around here, there's kind of a hat, and difficult to see, but Robert Simon thought perhaps a book there. This is the drawing that he did of what he thought was underneath our painting. And he was trying to decide whether that was actual pentimenti that was underneath our painting, or whether it was a different portrait entirely. And that was really a crucial thing, because it would make our painting the first in the series, and then it was, because there's pentimenti there. And if it's not, then you have to kind of work out who is that painting of that's underneath. His thinking was that because Cosimo wanted to be portrayed as powerful but passive, he thought that perhaps there was a different conception underneath, where this hat is like a scholar's hat. So it's possible that he had represented Cosimo initially as a scholar rather than a warrior, so that he was in that passive position, but then ultimately they decided to beef him up and put him in armor and so on. So this is what we were trying to work out. Our painting was obviously painted in large part by the master himself, Bronzino. This is what Robert Simon contended as well. Here we can see a fingerprint from where the reflection has been painted of the rosette, and then he's just lifted some of the paint by touching it with his finger, which is a nice touch. But here we see where the helmet should have been painted in but hasn't, as if a copyist, someone copying from a cartoon has missed something. So it's possible also that some of this painting was done by his workshop. So we wanted to unravel all that. The painting on the image on the left is Robert Simon's X-ray, which is very difficult to make out. We did another X-ray, which is the one in the center, which was much clearer, and you could start to see the image underneath much better. But you couldn't really see much of what was going on here still, and there was all sorts of things in the way, because the X-ray technique goes fires X-rays right through the painting, and anything that's thick, like a nail or lead white, which historically is a pigment which is dense, and so it shows up in X-rays, you can see. But that's the only image that you can really, only pigment that you can see, because it's so dense, is lead white. You don't get to see all the other elements. The one on the right was an infrared shot that we did, which also was useful in showing up more detail in the face and head. But so you can see there on the image on the, well, in both images, I guess, but particularly the image on the right, you can start to see, if I can get my cursor going, you see the eye here, and an eye here, and here's the contour of the face of the guy underneath, and the chin, but still quite difficult. So we wanted to test this out, so we headed to the synchrotron, and that's the particle accelerator is in that very, very large building. It's a huge ring. I don't really have time to go into that. I'll never get anywhere near the end, but Marieke will talk about the technique in her talk. The electrons go around and round in that huge ring, and then you fire them through a hatch into your painting, and you get an image as a result of the energy that's emitted from the particle colliding with your painting. We'd taken a different painting down there before, just to show you what it's capable of, this technique. This was a portrait of Henry VIII that we had in the collection, and those other two images to the right are showing that it actually even images gold. This is gold leaf that's underneath Henry in this area and this area, to the point where you can really see each leaf, the lamellae from where the gold ducat probably was hammered out. And it's quite a remarkable thing to see. Things like individual brushstrokes you could see. So this is the iron map. So this is iron imaging a pigment like an earth pigment, like ochre. And you can see two brushstrokes here. One here, and then another one here, which you don't see on the painting itself, which is underneath. So it was initially, the neckline was placed there, and then it was painted over with this black paint, and it was replaced just slightly to the left. So you're with this technique, you're starting to be able to see each paint, each pigment, and as it was applied, and how it was applied by the artist 500 years ago. So it's really gives you incredibly detailed information. It even imaged the wooden plank that it was painted on, which was in this case oak. So it had growth rings from which you can, if you're clever, derive a date for when the tree was cut down, which they did. And it came up as 1520, and the location was here in Kent, where I'm from, in somewhere around Knoll Park in Sevenoaks. So that was incredible. So we had high hopes for Cosimo as well when we took down Bronzino's painting. That's Daryl Howard on the left, and it's myself and Paula, my colleague, who we did the experiment together. And I've got this slide in partly just to show you the scale and complexity of the piece of equipment that was being used, which has now been entirely superseded really by the piece of equipment that Bruker have produced, which Marieke now uses and practically puts into a suitcase and gets on a plane with. So that'll be interesting to as a comparison. You have to get the painting very, very close to the sensor, and that you can just see Paula in between the painting and the Maya detector just there, because you have to get it very, very close, and then it scans across, so you don't want it to actually contact the painting. And then you sit in the hutch and you wait for the results to come in, and here they are. And this is what we saw. So the painting is made. Painting painted at this time would generally have these sorts of pigments in. So lead white, the historic lead white pigment, vermilion, which is got a mercury base, is based on mercury. The earth oxides, which you'll see by looking for iron. Lead tin yellow, which, as I said before, is also got lead in it, but also tin. Carbon black, which won't be imaged by a synchrotron, by X-ray. The blue pigment azurite, which has got a copper element in it, copper atom in it, and that's how you can identify azurite as well as some other pigments, but you can distinguish them. And a red lake is another one. You can identify that by identifying the base that the red dye is cast onto. So I'll just run you through the maps, the most important maps. We looked for the elements that we hope to see representing paint that was applied by Bronzino on this painting, and to try and get some more knowledge about what was going on. The crucial thing also is that it also images paint that's underneath the surface, and also the X-rays don't have to go right through the painting, so you don't have to see the nails and all that sort of stuff anymore. So it bounces off the surface, but it penetrates the surface, so you can see the underlying paint of whatever image might be painted underneath. And so then you have to separate the two. So, for example, the mercury map was a good one, because that's the red that's added to the lead white to make flesh color in this instance. And can't see my cursor, but here you can see really clearly a hand, which doesn't appear obviously in the painting. So it's obviously underneath. There's also another hand here, which also contains the red pigment vermilion. So this is the mercury map. And there's another hand here. And if I go to the next element, so copper, which identifies azurite, for example, so you can see the blue background, and there it is imaged in the XRF map. And what was I going to say there? Yes, the lighter the white means the more pigment is there. So where it's black, there's no azurite. Where it's white, there's a lot of azurite. And where it's sort of grey down here, there's a little bit. So maybe it's mixed in. I think it was mixed into some yellow because it represents the green of the leaves on the laurel. So you can start to look at mixtures as well, how the artist was mixing their pigments together. These are the iron map, which shows the earth oxides. So you can see the book very clearly in this one. So maybe a yellow ochre for the page, the edges of the page of the painting beneath. You can see it's not here. And also possibly in the hat, the scholar's hat, because that's imaging quite clearly. Lead tin yellow, so you could see that earth oxides were used for the rivets on the armor, but also probably topped with a brighter yellow, the lead tin yellow, to give it for the highlights. And lead white, which is used in the face and hands, but also for the grey of the armor. And here for the hand that's underneath, that you could see also the book. And then gives a nice clear image of the hat again. And then you can, Darryl likes playing with these things and putting together different colours to see what he can get. I mean, for one thing, they've got amazing clarity, so that you can see a lot. The hand holding the book here is so clear, it's beautiful. And the hand here and the hand here. But also it's just a beautiful image in its own right. And that's the image that ended up on the front page, the front cover of the Burlington. You can also see something going on here. There's a difference between the background here within this line to what's going on here. So we investigated that. This is where the incised line is on the painting. So we were investigating that. Another one of Daryl's pieces. That's vermilion iron oxide and manganese, which again very clearly images this change in the background. This one even better. So that's purple. The purple here that you're seeing is an arsenic impurity that we found in the azurite that was used in the bottom layer of the background. So where it was first painted blue, the azurite had a arsenic impurity in. So imagine this was painted across the entire thing, but later on another arsenic, azurite layer was painted for the background. The background was repainted, but only in this area, inside the incised line and going over the hip. So what we think was that the incised line was put there with an idea to cutting this painting down at one point. And they decided they would go, they didn't like the 3/4 length after all, they were going to go back to half length. So they put the dimensions on, inscribed it, painted over this bit of the hip because you weren't going to need that anymore when it's at that size, and we're going to cut it down. But they never did. And here again is where that azurite has been painted over the hip to obscure it, and then it was repainted again afterwards when they decided not to cut it down after all. Okay, how much time have I got? About 5 minutes. So I'll be whipping through these last ones because the next challenge for us was to try and make sense of what the image was that was underneath. So I brought all the maps onto put them on an iPad and traced them off. Anything that was on the map, but that I couldn't see on the painting itself, I put a line around. And then, so here you could see the lips, the eyes that were underneath, the arm, the hands, and so on. And then that formed this drawing here. So that was an image, as best as we could do, of what the painting was underneath before it was painted over or modified to become the Cosimo and Armour painting. And in trying to work out whether it was a pentimenti of the Cosimo painting or something else entirely, we were lucky to find this painting here, which is obviously very intriguingly close to the image that we have traced off from underneath our Cosimo in Armour. So we're trying to work out what was going on there. This was a drawing that was in the Getty that was a study for this painting in the Nelson Atkins Museum in Kansas. And when you take that, trace off the portrait underneath our Cosimo in Armour, and then you drop it onto that drawing, it's a really, really close match. So then it was intriguing to work out whether the painting underneath our painting was this guy, and whether it was just a different portrait, or whether this is Cosimo. And he first of all was portrayed as a scholar, so that he's passive. Interestingly, you can see he's got a sword, so he's passive, but he's also armed. And the really interesting thing was that the Nelson Atkins had done an X-ray of their painting. And although Bronzino's painted him as a scholar, you could see here there was actually a shield. And you can see that there's also, when you look at it carefully, there's actually armor under there. And there's another hand here. So it's exactly the reverse of our painting. You have a painting of a figure who was first painted in armor, but it was then changed in the course of painting it. That's the armor that is like the original depiction of whoever this is, who then became clothed as a scholar And so the question then is that an image of Cosimo, or is it someone else? And this is a painting, a portrait by Pontormo, who's Bronzino's master of Cosimo de' Medici in profile. And it's similar, but I'm not sure it looks exactly the same. You can see the lips are much thinner, for example. But this is another painting by Pontormo, Bronzino's master, of Cosimo de' Medici, supposedly, holding a book, dressed as a scholar. So was that the basis for the painting of Cosimo, which was then modified into toughening him up to put him in armor? Or is it someone entirely? Recently, the Nelson Atkins have identified this scholar as someone entirely separate from Cosimo, which would mean that has implications, obviously, for Arpon. The composition is based on, as I've said, Charles V and his father, Bandineri. And these portraits of power, you know, they've been sort of intriguing us over for many years, whether it's of Cosimo de' Medici looking tough, or Henry, also with his broad shoulders. It was actually, his broad shoulder would have gone right the way across there. This is an addition which was wrongly painted on the right, which we actually ended up replacing. And here's another portrait of power, bringing it up to date, with leaders needing to look like tough guys. And that's what Cosimo had to look like at the time, because he was being installed by Charles V on a Florence that had been a republic for many years, after an uprising had thrown the Medici out. So he was trying to re-establish the Medici lineage as an authoritarian over what had previously been a fairly democratic republic. So really interesting parallels in history, and you can, as far as we can tell, the portrait underneath is likely to have been a different portrait that Cosimo started, abandoned at some point, finished it on a different panel, because he needed this panel to complete a commission that he'd been asked to do for Cosimo, of this portrait of him portrayed in armor with the expanded areas to include the laurel, which is the insignia of the Medici dynasty. And that's the end of my talk, and thanking our other authors and so on. So I think I'm going to stop there.
That's great, Simon. Thank you very much. Thank you very much indeed. That was brilliant. So I'll now introduce our second speaker. Just remember, please be putting any questions you have into the chat, and we've got a period designated at the end to for the three speakers to answer your questions. So our second speaker is Marieke Gerken. Marieke finished her master's degree in conservation for paintings and polychrome sculptures in 2019 at the State Academy of Fine Art and Design in Stuttgart. From 2019 to 2022, she worked in a PhD project at the Stadel Museum, Frankfurt, before joining Bruker Nano Analytics as an application scientist for art and archaeology in 2022. So please welcome Marieke. If you'd like to share your screen.
Thank you very much for the introduction. Just let me share and here. Okay, so thank you for inviting me here. Thank you for the introduction. What I would like to talk today about is, again, micro XRF scanning, so specially resolved micro XRF. I will also go a bit through the physics behind it and the principles that we can use in order to study historical paintings. All of the work that I'm showing is based on my PhD time at the Städel Museum in Frankfurt, where I had the pleasure to, during COVID lockdown, just select paintings from the gallery without having to discuss with the art historians if I can remove it from the displayed collection. But generally, what I would like to, or what I would aiming for here with my talk, is to show you the beauty of really seeing chemistry is something that we call quite often seeing the world with other eyes, because what we're basically doing is we're mapping the chemistry, and you can apply this to everything that you can imagine. So what you see here are, for example, leaves, a collection from Berlin, where basically, as Simon already explained, you see a correlation. The higher the intensity, the higher color that we display a certain element, the more is present. So what you see is basically, you see over time, for example, how a fern here in the upper left is changing his chemistry, because either the leaves have different requirements, the plant needs different elements that it has to incorporate, or the soil changes. We don't really know, but what we see is that basically different leaves incorporate different elements to different degrees. So you have color coded here, for example, chlorine in blue or potassium in green. And this is the beauty that is being offered by the systems that I have been using. Apart from what Simon showed with the particle accelerator, I use open beam systems that you can bring directly to your object. You can bring it directly into the gallery and then just start scanning, or you can just put everything below. You don't have any sample preparation. You don't need to destroy anything. You can just put something below your spectrometer, and then you can start right away. So you can apply this also to fairly topographic samples, as you can see here, for example, on a case of a dinosaur fossil from China, again, with imaging revealing the beauty, or the giving us the opportunity to access information visually. And this is something that we as human beings are really prone to understand, because we are visual beings. Coming a bit more to the topic we are discussing today, so cultural heritage analysis. Here you see basically a tile, a Delftware tile is a sort of tin glazed earthenware. And again, here we can map the original materials, but as well the conservation campaign that has been applied. So on the right-hand side, you see areas that have been conserved, also marked in the center with red. So we get a wealth of information, and then usually what we get if we acquire data, the acquisition is easy. The processing can take you ages, because there is so much information hidden. Now coming finally to our paintings, this is a, let's say, quite famous case, at least here in Germany, from Dresden Museum. They had the plan to do conservation treatment to this painting of Vermeer in the gallery, and we're doing preliminary examinations also with micro XRF scanning, revealing a little cupid that you can see here in the center in the LED distribution, LED L giving us information from subsurface layer. We will see that later on a bit more detailed. You see there's a little cupid popping up that you cannot see in the visible image displayed on the left-hand side. Now this cupid, if you take a look at the other elemental distributions here in the upper right, displayed on mercury and cobalt. Mercury, we already learned, this is mercury sulfide, a red pigment called vermilion or cinnabar, and blue being here related to a cobalt distribution that is a cobalt-colored blue glass brushed to particles and then mixed with a binding agent for application. So we see here a cupid that has been painted. Now, the funny thing about Vermeer is that he reuses the depictions of certain elements. So he uses the same paintings, the same furniture, displayed throughout his oeuvre. And we have here a second case, a young woman standing at the Virginal from around 1670s, where we see potentially exactly the same painting being displayed. So the conservators started removing the varnish, and eventually they figured out that the layer that is on top of this original cupid is of a different color than the original background wall displayed. So here, this is a later conservation treatment where someone decided to just overpaint the Cupid painting. So they removed it. There is a nice documentation that you can find on YouTube on that. But here you see, this is the power that we have accessing something with our own eyes, allowing us to distinguish original from later editions. And it's for a reason that the BBC recently ran a headline saying something stirring beneath the surface, because we have more and more imaging techniques approaching not only micro XRF scanning, but also other techniques that reveal information that were hidden before because we just cannot see it in visible light. And I would like to highlight some of the stirring findings that I found during my time at the Städel Museum. But first, let's take a look at what actually is a painting, because it's, I would say, one of the most complicated samples that we have to analyze in cultural heritage analysis. You see here displayed on a painting from Italy again, beginning 1500s, from Giovanni Battista Cima da Conegliano, a Virgin with a Child. Basically, what we use or how it's being constructed requires the need for us as conservators, in order to examine it holistically, to use different imaging techniques and to use different wavelength ranges in order to access different information. So on the left-hand side, you see, let's say, a standardized buildup of a painting. And what you see is it's a very, very complicated multi-layer system. And within the layers, you often have different pigment mixtures of pigments, organic binders, additional modifiers that make your paint, for example, run more smoothly or more stiff, depending what you're looking at. So usually we have a support. We saw on Simon's talk, the poplar panel. It can also be a canvas or any other support, depending a bit on the century and the region where we're going. And then you prepare this with usually a seizing, which is often a glue or starch layer. Then you apply a prime in order to have a flat surface on which you can then start preparing the depiction by usually an underdrawing, which is a compositional drawing that you have to apply in order to fix the composition before painting. And then you start painting. But a painting is also, in a certain time, historically, not a single layer, but it's an interplay. What we see as an optical result is an interplay of different layers that end up with translucent glazes, a varnish layer, and then on top of that, you might have conservation treatment. So we use a whole range of different techniques in order to access this information, to study these paintings. There is not the one technique that offers all of the answers, but micro XRF, what I have been using, or what I'm still using now, is giving a wealth of information we saw already from conservation to also subsurface layers. And why is that so? So in principle, XRF works as following. You have high energy X-rays that create inner shell electron vacancy. So electrons from inner orbits of your atom are being released. And these vacancies have to be refilled by outer shell electrons. In order to do that, they need to release a certain amount of energy. And this energy is characteristic of the transition and of the element that we're looking at. So we can detect a broad range of electron transitions from a broad range of chemical elements, being copper, being lead, being iron, all of these being distinctive for certain pigments or other type of materials that we that have been used, not only for paintings, but for all sorts of materials. So with the system that I have been using, we have the great advantage that we use perpendicular excitation. So generally, hardware-wise, we have an X-ray tube. It's being focused to a micrometer diameter beam. And then with these ones, we shoot on our surface, and the resulting X-ray fluorescence, the resulting released energy we detect with a so-called silicon drift detector. With the setup that we're using here, or the setup that I used with my system, is perpendicular excitation and then a quite quite high angle of 60 degrees for detection, allowing us to gain more information also from subsurface layers. So this is now then translated into a spectrum that you can see in the upper right. And you see these tiny peaks popping up. These are the specific energy lines of the different elements, depending on the sensitivity of the instrument, as well as on the amount that you have, they are higher or lower. And from this, if we apply this to 100,000 to million single spectra over a whole area, we can map elemental distributions. And these elemental distributions in painting, Simon already mentioned it, can be correlated in some of the cases quite well, in some of the cases more or less to certain pigments that have been used. So we already learned about vermilion, mercury sulfide, a very, very bright red pigment with a high tinting strength, which has been used throughout since antiquity, as has been lead white, both from or the vermilion from a natural mineral occurrence called cinnabar, but also industrially or manufactured by the people. So since early antiquity, there's already people producing pigments in order to paint. We see here azurite as an example of mineral mining and exploration, verdigris, green copper cells that you might know from rusty copper surfaces, as well as ochres, one of the main or the oldest pigment actually that have been used, because we have so many deposits all over the world without any need of preparation except for a bit of washing and grinding. We also see, as Simon mentioned, organic colorants. Sometimes we can see the substrates on which they have been precipitated, for example, calcium carbonate. We sometimes also gain hints on, is the lake that we're looking at from a plant or from an insect origin? But here we come to the limits of what XRF can actually detect and also identify and visualize. So here we get general information, but we're not capable of really identifying a certain compound or a certain pigment. These pigments were then mixed with binding agents and applied on the painting. And now I finally come to some, let's say, results from my time at the Städel Museum. For all of you who don't know the Städel Museum, it's located in central Germany, in Frankfurt am Main, and it has a quite nice collection from early medieval to contemporary art, also a very, very large graphic collection. So I had the pleasure of working with these paintings mainly during my time there from 2019 to 2022, using, as I said already, the COVID lockdown in order to just select the paintings that I would like to analyze. I try to do a very broad survey because we have a lot of single case studies. But what I was interested in is to see, can we detect broader changes in the art technology, in the way paintings are being created over time? So it all started with this piece that was before my time at the Städel Museum. This is one of the earliest examples from the Städel collection. It's called the Altenberg retable. It was created about 1330, so very early medieval large-scale altarpiece, and you can see the very well preserved medieval decoration here on the front side. However, the back side was heavily damaged at a certain time, and then during the Baroque, so in the end of 17th century, it was heavily overpainted and redecorated into this floral, with floral motifs. So before the Städel acquired one of the M6s that you can see here, my now colleagues came over to Frankfurt in order to scan the altarpiece to show what can we make out of or how can we access the original? Is there something left? So they had 2 days of scanning, and they were capable of scanning nearly half of the back of the altarpiece, not being able to move it anywhere because it's in such a, or the backside is in such a bad state of preservation that you are not allowed to remove it from the gallery. Even moving it or getting it from the wall in the gallery is already something where you have to make some sort of commitment to lose maybe some of the paint layers. So something that's very fragile. So it's better to bring the analytical techniques directly to the instrument. And here you can see a first result from one of the panels from the back. But basically we can see shadow figures popping up below the surface, giving us some indications of what has been depicted here originally. So if you follow the blue arrows, what we can see is there might be a little tower, and there might be something that looks like a palm leaf, indicating that this is a depiction or has been a depiction of the Holy Barbara. Now applying this to more than 2 square meters, so nearly, as I said, half of the reverse of the shrine, we can identify and visualize the whole range of iconographical decoration that has been here initially, with the central figure being Saint Christophorus that carries the little child, Jesus, on his back, so indicating not even the medieval painting that were originally there, but also giving us an indication that this might have been a location where pilgrims stop by in order to make their devotions, because this is a usual setup that you would have for a pilgrimage church. So over the time, the Städel Museum could get some funding in order to get PhD positions like myself, and also equipment. So I started applying the same principles to the gallery, and I would like to run through one of my favorite cases that you can also see here on the back, being a painting by Rembrandt called The Blinding of Samson. Now this is a large 3x4 meter large scale painting that Rembrandt used in order to show a bit off. So this is the time where Rembrandt has moved to Amsterdam. He has established himself as an artist. He's leaving the portrait painting and going more to large scale scenes. So this painting has been under discussion for decades now, because it has a really neat composition where you have these 2 diagonals all facing to Samson, who's just being blinded, while Delilah is leaving the cave in which the scene is laid, holding his hair that she cut, the strength of his power. I'm very happy to announce that we are finally publishing the results that I will be presenting now in a special issue of Art Matters that will be coming out quite soon, I would say. So during the lockdown, we had the opportunity to remove the painting from the wall, unframe it, and then I did 1 month of scanning, here taking far more time than was done with the Altenberg altarpiece, because I wanted to look at the working traces, the traces of application that I see on the surface and also below. So in the end, I used 17 scans in order to map nearly the entire surface of the painting, just leaving out the bit here in the top part where I didn't have the time anymore, and 1 detail scan to which we will come later. You can see one of the setups here. So this is one of the last rows on the top. We also had it on an easel, quite high, fixing it additionally on the wall. So it was a very intense time, but it was worth it, because basically bringing all of the results together, all of the single scans that I did, you can really see how the painting has been created. So let's start. Let's go through the general setup of a painting, starting here with the first priming layer, which you can see in the iron distribution, because at a certain time, in difference to the Bronzino, they started using oil-bound pigmented, so colored priming layers. Here on the canvas, you see the iron is correlated, or most likely coming from earth pigments, ochres and umbers. You see it only in bits. So the very bright areas here are from a conservation treatment, where we have areas of losses that were retouched. But in small areas, especially in dark areas, you see a detail zoom. you see these broad structures that run throughout the entire painting that are most likely stemming from the first red priming layer, which, and this is the reason why we cannot see the iron distribution overall for the priming, was then covered with a second priming layer, which contains a lot of lead. Again, lead white. This is a gray layer, probably mixed with a carbon black in order to get to the gray color, which we cannot see with XRF. But we see the lead distribution. And this is, let's say, offering a lot of insights into how the priming has been applied, because again, we see these broad structures. They are applied in 3 rows. So you see here, row number 1, row number 2, row number 3, indicating also in the way they have been applied in the traces that we see that here's probably a priming knife being used, which is a tool that is described in also art technological treatises from the 17th century. So we gain a wealth of information. But what I found the most intriguing is if you take a closer look again to the lead distribution, but also to the mercury distribution, so our vermilion red pigment, we also see sketch brushwork that do not correspond to the final forms that you see nowadays. So what we see here as a mapping is basically the underdrawing compositional sketch executed with a brush that sometimes does not follow the end depiction. I would like to highlight especially these spider-like structures that you see on this side and on the mercury distribution here close to one of the soldiers that correspond in his case with the hand, with a closed hand. So what I assume is that here initially there was the same position planned for the soldier that is now raising his arm with a sword. And you see furthermore that nowadays we see that there is a shield depicted, while originally the brush drawing indicates that he has originally not held a shield, but was depicted only in full garment. One of the most intriguing compositional changes I could find in one of my last scans, which was a great relief in the background. So you see here again, mercury distribution, a head popping up in the nowadays dark curtain. And this is something that is really interesting because you see basically a sketch of another soldier that is not being depicted in the final image. With a helmet in 3/4 view, you see maybe this is the indication of a shield or a raised plate of his shoulder armory, basically breaking what has been described as Rembrandt's mastership, the diagonal composition facing towards Samson on the ground. So this one is breaking it. It also intensely sets like a large group of people that are on top of Samson, but it's not in this, let's say, very intrigued compositional structuring. So basically here in the end, you see a mapping of all of the underdrawings, and some of them correspond to changes, but we generally see them more in darker areas because there is no lead white again being used on top that shields any information that I get from the subsurface. Additionally to these brush drawings, we also have underpaintings. Now, an underpainting is a very coarsely applied layer that initially colors the ground, the pictorial ground, and it can also have a compositional function. In this case, we have two types of blue underpaintings. Again, our smalt, the cobalt blue glass, if you remember this one, and the copper-based blue pigment, in this case identified by invasive analysis as azurite. In these cases, if you take again a very close look, you see differences to the final depiction. You see how they also participate in the way the composition is being created. So you see that the soldier, for example, here in the background is being left out. We have a structure that could be a spear, a similar structure being left out here in the right-hand soldier that is now raising his arm. So there is a lot of changes going on, and what I assume also changes that were being, let's say, compositionally adapted throughout or during the process of underpainting. And so Rembrandt continues. So this is actually not a work that has been finalized from the first stage, but it's a work that he is, or a composition that he's modifying and changing throughout the whole layers of his painting. So he's intensifying it more and more. So for example, the spear that I just mentioned that you don't see nowadays in the right-hand side of the right-hand soldier, this was actually, again, already painted. So we see it in different elemental distributions, indicative of different pigments, allowing us to deduce that this was painted. And the very, very interesting fact here is that there has been a workshop copy of this painting that was unfortunately destroyed during the Second World War. It was originally in Kassel, so also central Germany. And in these we only have a grayscale image left, but this one shows a spear at the same location. So probably, and we know that Rembrandt had a large workshop and he was training also apprentices, they were using copies in order to learn to imitate his style, or to learn how to apply or how to work in the same way that he does. And this continues. I have far more examples only on this painting. So you see, here's work in progress until the very last layers. Why the very last layers? Because different to the LED-L distribution, LED-L transitions more likely because of the higher energy coming from subsurface layers. We can also visualize the LED-M transitions from XRF analysis. These are low energy lights that are more likely to stem from surface layers. And you see here in the lower right, at the very, very last layer application of, for example, the blue background, the blue sky, we have these not corresponding structures that show that he reworks the outline of the shadow figure with the spear on the left-hand side in order to intensify the contrast between the bright background and the dark figure. So here, this is work in progress until the very, very last layers. Now, I'm running a bit out of time, but I would like to bring this now to a broader scale, discussing or introducing my PhD topic, because what I was actually looking at mainly is the underdrawing. What we already learned is the compositional drawing. So this is commonly or historically examined using infrared radiation, because we can transmit paint layers, but then the infrared is being reflected on a white priming, which is historically until the 16th century the most common priming, but absorbed by dark underdrawing media. Now, dark underdrawing media are mainly carbon blacks, something like soot ink, or you have burnt plant or bones crushed again and then applied with a binding agent. You see one case here where you see basically in the visible, you see the paint layers, and in the infrared reflectography, so we detect the reflected radiation, we see these hatchings and the lines indicating the composition before the actual painting process. Now we know that apart from these carbon blacks, a large palette of other materials were used, also very commonly for writing and for drawing. So we have metal points where you use a small metal piece in order to draw with that. We have iron gall ink, one of the most common inks until the 20th century, where you use iron from often vitriolic compounds, so iron sulfate, and you mix that with water, wine, and galls. So these infectious growth on, for example, oak leaves. So a lot of materials, red chalk, that were used throughout the centuries by artists, the same that were painting, also were drawing on paper with other materials. So why shouldn't there be the likelihood that these materials were also used for underdrawing purposes? Now, we don't see them necessarily with infrared reflectography. Here depicted on a little poem, that you can see on the top of this drawing that is was created by either Michelangelo or Sebastiano del Piombo. And this one fades away the more we go into the near infrared. So you see here at 1060 nanometers, you still see it, and then eventually it fades away. So with common infrared reflectography, you would not see it. But we know from a lot of different sources that these materials could have been used more often also for drawing on the pictorial ground before painting. We have cases from heritage science. There is even a conference dedicated to the underdrawing, which discusses also non-carbon black underdrawing materials. We know of other heritage objects like wall paintings, for example. Sinopia is indicative of red underdrawings that you use before you start painting on a wall painting. Also, other types of polychrome objects that are not necessarily paintings, but follow a very same layer structure, like these reliquia boxes here. We also have depictions of red underdrawings on panels, or we have depictions of metal points, as well as historical treatises describing these different materials used for underdrawing purposes. So I had the pleasure of being in a gallery that has been doing art technological examinations on the whole collection since the early 1990s. So we have a very good foundation of knowledge on the underdrawing, because since then they used infrared techniques, photography, as well as reflectography in order to study the underdrawing. So looking at these broad range, being a total of 287 paintings, and then just looking at one factor being the visibility of the underdrawing in a common infrared reflectography image, you see a lot of differences between different regions as well as different centuries. So for example, we see that in the Northern Europe, we more often, here displayed in dark blue, we see the underdrawing in infrared, while in Southern Italy, or in Southern Europe, in Italy, for example, we don't see it as much. And it starts being less and less visible to an earlier degree already at 1500. A little less, but also in Germany, but then the Low Countries, so Belgium and the Netherlands, we still have most of our underdrawings being visible. And then it fades over time eventually to a state where we hardly see the underdrawing in infrared, indicating as one factor that we have a change of material and of painting technique. Now, the visibility is not only indicative of the underdrawing material used, but also of different other impacting factors, like the general setup of a painting. But what we see here is a change that starts earlier in Italy and approaches more slowly the more north of Europe you go. Now, I would like to compare Northern Europe on the case of the Low Countries to Southern Europe. So looking for non-carbon black underdrawing materials. Here you see basically some of my results. So what I could see with using different analytical techniques, such as specially resolved micro XRF, I can visualize underdrawings that were invisible before, materials that have never been identified as underdrawing materials before, or that are very common underdrawing materials or drawing materials when it comes to paper or parchment drawings. We see less, so a lower or smaller group in the Low Countries than we see in Italy. Italy in 14th to 16th century, especially around 1500, you have an explosion of materials being used, indicative of a change also of the perception of the artist. So this is the artist evolving from very strict workshop rules where you follow, or where the creation of paintings is more related to being a arts and craft thing rather than an individual artistical creation. And this now changes at the border or between the 14th and the 16th century. And we see that in the materials and how they are being utilized. So in Italy, I earlier see a more individual approach of using materials in order to lay down the composition from, you see here again, Cima da Conegliano, iron gall into brass stylus, which before that has never been identified as a drawing material, or an underdrawing material for paintings, to multicolored drawings, which we hardly ever hear of when it comes to our technological research on underdrawings. And then evolving even further when we go into the 17th century now throughout Europe, you see the whole process or the whole strict rules of how you go step by step to the creation of a painting being dissolved into a very individual form of, I use underdrawings, I use palette remnants in order to quickly apply a brush drawing in order to lay down the composition. I use underpaintings, local underpaintings, oval shaped forms or rectangular shaped forms in order to create a composition directly on the pictorial ground, or to transfer a composition from a study on cartoon before. So here we have a dissolution of general techniques into more and more individual habits, allowing me, maybe as a sum up, to go or to change the knowledge that we have now on the Städel collection from underdrawings, unidentified or carbon black, to a more broader survey, because this is how the world works. It's not either one or the other. It's most of the cases a really large variety of different materials used, because what is an artist? An artist is not what we sometimes make of him or her, like an overhuman being that is so genius. It's a human being. It's like us. These are people that are trying to make it better, to improve what their final result is, and eventually also struggling with the work that they are doing. And with this, I would like to close my presentation. Thank you very much for your attention.
Thank you very much, Marieke. That was brilliant, fantastic. All right, so we'll move straight on to Rika. Could you unshare your presentation? That's great.
Yeah.
Yes.
Rika, if you can share yours. I'll introduce Rika. So Rika Pause earned her master's degree in paintings conservation from the Academy of Fine Art and Design in Stuttgart in 2018. She later obtained her PhD from the University of Amsterdam in 2024. She currently works as a paintings conservator at the museum. Here we go, the Museum Boijmans van Beuningen.
Great. Yes.
I'll let you, Rika, pronounce that properly, in Rotterdam, and as a heritage scientist at the Cultural Heritage Agency of the Netherlands. Thank you, Rika.
Thank you. Can you see my screen?
Not yet.
Oh, okay. That didn't work. Let's see. Because then I was kicked out probably. Yes.
Looks good. Great.
Yeah. Okay, great.
Okay. I just
Thank you for your introduction, and thank you for the invitation. Different to my fellow speakers, I will talk not about old art, but move forward towards modern art, into the colorful avant-garde. I will talk also about XRF, but also talk about the technique of Raman spectroscopy that works complementary to XRF and can help, yes, in revealing pigments that the colorful avant-garde worked with. This project was part of a bigger project about all kinds of materials within the 20th century cultural heritage sector, which ran from 2020 to 2023. And similar to Marieke, I was allowed to study paintings in lots of collections because they were all closed. First of all, what am I talking about when I talk about the colorful avant-garde? I talk about the artist
sorry,
movement in the
Rika,
beginning of...
excuse me.
Yes.
Are you going to switch to slideshow mode or to full screen?
Oh, I already switched to. I'm already in the slideshow mode on my desktop.
Oh, okay.
You don't see it then probably.
We're seeing just the view with the
Yes,
slide
this is
down the
this.
side.
Let me see. Let me try something differently. It's probably we're not compatible with Zoom from the government, and sometimes there's weird things. Let me see if this works better for you. Do you see it now better?
Yes, perfect. Thank
Okay.
you.
All right. Then this took this little trick. Okay. So let me start again. So talk about the colorful avant-garde. It's an artist movement in the beginning 20th century. We're talking about a different style than what was usually taught at the art academies. We talk about strong color
Sorry, is
choice,
it possible
also
to
abstract
remove
stuff.
this triangle, this rectangular at the bottom?
A rectangular triangle.
There's a little pop-up at the
Rectangular
bottom.
pop-up window.
It's only small.
I don't see it at my screen.
Oh, okay.
Is it this thing here? No,
It's
I don't see anything at my screen.
okay, so you probably can't remove it then. It's not fatal. It's just slightly covering one
Okay.
of the images. Thanks anyway.
Is it this thing?
Yes.
No. Okay. I thought you maybe can't see it. Okay, then you can see it. So we have to deal with this, I guess. Does it work better like that? Yes. Okay. All right. So we're talking about various stats, strong color choice, and also occurrence of a new class of pigments, which was introduced in the beginning 20th century, and it's called synthetic organic pigments. So different to the pigments that Marieke and Simon were talking this morning. It's about a new class, which is completely different to all the inorganic pigments that were used in previous centuries. So synthetic organic pigments are colorants with a carbocyclic ring skeleton, like in this picture here. They are produced in a laboratory and they're insoluble in binder technically. They have been developed in in the second half of the 19th century, initially also for textile industry. Which means that you have to imagine before that you could dye your textiles with red or blue, but not with a violet or with a strong neon yellow or this kind of stuff. So what we experienced then was a strong, almost patent war with chemistry industry trying to find out more and more dyes and pigments to overrule a different industry. So, for example, when I don't know if you know the big industry firms of this time, like BASF, Bayer, IG, color industry, when they patented a dye, no one else could produce it. And this is what also caused lots of developments. I think like in the beginning 20th century, you had like it's something like 10,000 different dyes or pigments developed per year. Initially, as I said, they were developed for the textile industry, but of course they were also adapted fast to the sector of color industry, because also what happened parallel to the development of the pigments was that artists would not produce their paint themselves anymore, but would buy tube paints that were industrial made. So it was not only a pigment and oil, but there were like pigment oils and substrate to keep everything in balance. So you would just buy something you were not really sure of the content. Also sometimes with these pigments. So why are these pigments so interesting to study? What I have here is an example of a pink neon pigment, which was developed in the 1920s. I don't know if you know German. It has been developed in Germany, but what it says is the really strong pink tint is the fresh dye or the fresh pigment, and after 1 day of the light exposure, you get this more dull tint. So you can see the really big problem with these pigments is they are not really light fast, which is okay in terms of textile industry. I mean, you would not wear your dress or your shirt longer than probably 10 years. But when we talk about artist paint choice, you want something to create, of course, for eternity. And we know that they have been used in the color industry from color charts, like, for example, in this case, from Royal Talens, a Dutch paint manufacturer from the 1930s. How do we detect SOPs? So the difference to inorganic pigments is they have a super small particle size. Just to give you an imagination, when you're in the lab and you're trying to recreate a color, and you accidentally drop a little bit of the pigment, you can't even see it on the table, and you try to clean later with ethanol, the whole table will be pink. So you need only a really, really small amount to give color to your paint, and you have a small particle size. And what I already said, in the tube paint systems, you have complex paint systems because they have such a small particle size, you need lots of different ingredients in the tube paint to keep it into a paint system. What we usually use to make them visible is micro-Raman spectroscopy, because this technique is highly sensitive to synthetic organic pigment identification, but comes with some problems like fluorescence, or if you have a mixture, it can be problematic. How Raman spectroscopy works in comparison to XRF, I will talk about later. When you want to find a SOP in a painting and you're not really sure if these SOPs have really been used in painting, you face the problem that it's really complex to take a representative sample. What I already said, you have a really small particle size, and you cannot really go to the collection and say, hey, you have a really bright red pink in this painting. Can I sample it? If you don't really know if there's actually a SOP inside. Also, really often modern paintings have a really smooth surface, not varnished, so samples will immediately show. So what I did in this project is I adapted a combination of a non-invasive approach of handheld Raman spectroscopy and handheld XRF, because then I don't really face with the technique, which I will come to later, the problems of fluorescence. So Raman spectroscopy. I don't really go into details now. The only thing that you have to know is that Raman spectroscopy works with a laser. So we have a monochromatic light source of a certain wavelength, which hits the sample, and you have different reactions of light. You have transmission, you have absorption, but you also have scattering. And Raman works with inelastic scattering. And this signal comes back to the detector of the Raman spectroscope, gives you a fingerprint of a pigment. So different to XRF, I don't get information about the elements. I get a spectrum which is individual for a certain pigment. So for example, in case of vermilion, I don't get the information for mercury, but I really get a specific peak that is individual for only vermilion. So before I went with this approach on actual paintings, I tested the approach on paint outs. But I already talked about, we worked together with the Dutch painting company Talens, which miraculously kept all the recipes from the paint production. I digitized the paint recipes and I was able to match them with the color charts. And this way I could actually see also how sensitive our handheld Raman device from Bruker was towards these pigments, and how this device also would deal with the problematic of varnish, because of course very many modern paintings are not varnished, but there are still some paintings that are varnished. And if you would take a sample with a varnish and put it into the micro-Raman, which is normally a stationary instrument with a microscope, you would face the problem of varnish. But in this case, it surprisingly went really well. We were able to measure and identify the pigments in the samples also when they're varnished. So we went to the paintings. As you already can see here on this picture, I combined the two techniques of micro-Raman spectroscopy in form of the handheld Raman, and I did point XRF. And I aimed to measure the same points with XRF that I measured also with Raman to get the complementary information, because not all pigments not all pigments are Raman sensitive. For example, I can't see cobalt blue with Raman, and then I need XRF to give me the complementary information that there's, for example, cobalt in the blue paint. So we went into Dutch collections, and of course there are lots of paintings, so we had to put ourselves some aims and borders for the choice of the paintings. So what we wanted to do was to create a broad overview of early use SOPs, because this theme or this subject is not really much studied yet because of the reasons I told you earlier. We wanted to evaluate a non-invasive approach to detector stops, and we also wanted to focus on the consequences for conservation and restoration. Like, can we make direct links to light sensitivity, or also some of the synthetic organic pigments are sensitive to solvents, so these kind of topics. We selected paintings between 1980 and 1950, and we were especially looking for a colorful palette choice and necessarily not only in one group of artists. First, we studied paintings with UV and visible light, and then did handheld XRF first, and then handheld Raman, because we always did XRF first, because there's one pigment that you should not study with handheld Raman, which is copper arsenide, because it will leave a burn mark, because it cannot handle the laser. The burn mark is really small. You will only see a little brown dot, but you want to keep it non-invasive, so that's why we chose for this order. We went to 8 Dutch collections. Maybe you know some of them, maybe you don't, but just for the overview. And I want to, these are the paintings from different times, and you see it's quite colorful. And I want to talk today about 2 examples, and with which I want to show how complementary XRF and Raman are in this case for synthetic organic pigments. The first example is a still life of palette from a Dutch artist Wijnzouw, and the painting is from 1940. And I chose this painting because of the really bright colors on the palette, and because I was hoping I could maybe match or find some indication from which brand the paint tubes were. So this is how the surface looks like, and I studied every single dot on the palette, which you can see here. And I want to focus. If you compare the results here, for example, you see in the spot number 1 that I found pigment red free and chrome orange with Raman, but I didn't find any chromium or pigment red free, because probably the settings from the XRF standard settings that I used were not sensitive enough to find a little really small trace of chromium, which Raman was very sensitive for. In the case of spot 2, you see that I find pigment red 83, also synthetic organic pigment with Raman, and with XRF iron. So you can also see, even if you find a pigment or information for a pigment with XRF that explains the color, like in this case iron, which you could attribute to an ochre, in modern paintings it's not enough. You need to do Raman as well to see if you have any complementary information. And the most interesting case in this painting for me was spot number 4, because I found with Raman Prussian blue, ultramarine, and pigment blue 8. And with XRF, I found molybdenum and cobalt blue. What is that? I can't see cobalt blue. And the interesting thing is that the molybdenum is part of pigment blue 8. And I found it really striking that molybdenum, a really weird element that you would not necessarily expect when studying pigments, is apparently in such a high concentration with a synthetic organic pigment together that you would find it in XRF. So what we learned from this, as soon as we find molybdenum or tungsten, which can also be attributed to this pigment in XRF or MAXRF, we always have to search for this kind of specific pigments. But I will go more into the details from these pigments, because I was, of course, curious, what does this mean for the conservation of the painting? So the pigment blue 8, which I found, belongs to the group of phenol pigments. And what you can see here on the picture is that they are quite neon blue. And this is also how IG Colors or IG Farben industry sold these pigments after the patent in 1913, namely as neon pigments of the 1920s. But in the 1920s, art historians and art technologians like Wagner, for example, it's a German chemist and art teacher, said that these pigments gained real importance because they were able to precipitate the neon dyes or basic neon dyes that there was no other technique beforehand that would actually make this able. But in 1993, Hebs and Hunger, also chemists, said that these pigments have a really poor solvent resistance and have limited light fastness. So studying this painting, I got this information that I have to be careful with my light settings, but also when cleaning the painting that I might induce or that I might have to deal with a solvent sensitive pigment. And this is how it looks like. So yeah, we don't know yet how far this pigment maybe have aged, but it's a subject to follow-up projects to see if maybe we can reconstruct the original color tint or predict how it will change also in working together with microfading. The second example I want to talk about is the Dutch expressionist group called De Ploeg. And this is an artist movement that started in 1918 in Groningen. It developed in the 1920s and 1930s and was really going for super bright colors, also a little bit abstract, but yet that's what you can see here also on the pictures. So also in this case, I was really curious if the artists maybe have used synthetic organic pigments in order to get these bright colors. Because what I also forgot to mention is that some of the artists in this time were really anxious to use synthetic organic pigments, and some of them were really eager. So there was also one group really going for it, and the other one was really against it because of the light fastness reasons. But some artists were just like, well, I want to go for the specific tint that I can't create with inorganic pigments. So I don't care basically about how the pigment will age. And also doing analysis, for example, with XRF and Raman together, you can get more behind this mystery if it's maybe a pre-mixed mixture of synthetic organic pigment and inorganic pigment in the tube, or if the artist mixed it together. And this is also what I want to talk about now. So these are the paintings that I studied from 5 different artists and from the 20s, 30s, and 40s. These are synthetic organic pigments that I found. So there are a lot of synthetic organic pigments in these paintings, and to make it more comprehensible, I put them into a timeline. So what you can see here is that especially red synthetic organic pigments have been used during the whole time, but that blue synthetic organic pigments, pigment blue 52 and 60, were only used occasionally in the 20s. So this was for me really interesting to study, also because synthetic organic pigments are mainly expected in this time in the red and the yellow colors, but not as much in the blues, because you have a lot of blue pigments, for example, Prussian blue, ultramarine, that have been used centuries and are established to the palette. So artists would not necessarily replace these tints as fast as they would try to find more bright red colors. I found these pigments in these paintings by Jan Altink and by Jan Wiegers in the 20s. And also in this case, I was curious what these pigments mean for conservation. So what we have here is indentrine blue, is pigment blue 60. Interestingly, this pigment has been used for dyeing jeans, trousers in the 50s and 60s still, and is known for a really, really bright blue color and really light fast color. But it has already been used in the 1930s and 50s for artist paint purpose as well, opposite to pigment blue 52, which was more recommended for wallpaper and printing ink, so not necessarily for artist paint. And when we look further into more focused information, for example, by Schminke, who is a German color paint industry, or paint maker, Schminke says in 1912 already that pigment blue 52, so the one that was not recommended for artist purpose, is not light fast in direct sunlight, and you should not mix it with white. But that Schminke actually didn't want to put it into their offer, but artists really were longing for the tint. So what I said, artists did not necessarily follow the rules or the advice that you should not use this pigment because it's not light fast. They were really going for the tint. And for pigment blue 60, it's known to be light fast, but it has not been tested yet in mixtures. So this is really important information for preventive conservation, which is always good to add to the file of a painting in case it will be restored. So we identified the subs in these paintings, but one of these paintings here depicts Ernst Ludwig Kirchner, a German expressionist artist, in his atelier in 1925, and indicates that the Dutch artist Jan Wiegers and the German artist Kirchner may have worked together. So what I did is I looked for the vice versa paintings, so Kirchner painting Wiegers opposite to Wiegers painting Kirchner's. And I found pigment blue 60 and cerulean blue and got matching XRF and Raman spectra. Because cerulean blue, well, you can see it in Raman, but not necessarily so clearly like, for example, pigment blue 60. So I was really happy about the complementary techniques that I could apply to study these paintings and add information for art historical context, because after that I went further and looked for more paintings of Kirchner and Wiegers. And this specific combination of pigment blue 60, the synthetic organic pigment, and cerulean blue, I only found in those paintings by Jan Wiegers and Kirchner. And these spectra are so identical to each other that it looks really like they shared some paint or some paint recipe with each other. So coming to the end of my talk, conclusion and prospects. My main conclusion and prospect is that if you want to study modern art, you should start with a non-invasive approach like done here, and always combine Raman for the organic part and XRF for the inorganic part. And what also happened during my study was that I came across unknown organic compounds, and this is the limit of the non-invasive research. So you can go only that far, and then you have to take samples to go into a deeper level. This is what I came so far, and the prospects are that the paintings that showed some discoloration or some of the tricky pigments, like the ones in the two examples I showed, that we're going to study them with microfading and see if we can put relations between light-induced aging, and pigment information. And these are the teams I worked with my teams from the Cultural Heritage Agency of the Netherlands, this Academy of Fine Art and Design that also Marieke is associated with, and the museums. And with that, I want to thank you for your attention and excuse me for the technical difficulties in the beginning of the presentation.
Wow. Thanks so much, Rika. That was brilliant. There are three fantastic presentations. So we've got a few minutes for discussion. If our three speakers would like to put in their cameras and audio, unmute. And let me see. Oh, there are some thank yous coming in. Just a minute. I'll just change the controls so that people should be able to unmute themselves and start a video, not start video, but just a minute. Okay, yeah. So you're able to unmute yourselves. In the chat, there was a question from I think it's from Raphael. Are you still there? Still there, Raphael? Do you want to would you like to unmute and ask your question?
Hello, everyone.
Hello, Raphael.
Hello. Thank you for letting me making the question. I'm not fluent in English, so I will try my best to make it correctly.
Sounds good.
In this context of advanced painting restoration, how do current technologies, including multispectral captures, determine the original and accurate appearance of a historical painting, particularly in terms of color fidelity?
So that sounds like a bit of a different question to XRF. This is more to do with recording color accurately, yes?
Yeah, it's more related to that aspect. I was thinking if multispectral captures could improve indeed color reproduction.
Are any of our speakers?
I had
knowledgeable?
one of the Bronzino paintings, the ones that he wrote the letter about doing a copy of. I took the slide out, so I had too many slides, but I have another slide there with the painting that he did do the copy of, that Cosmo was very keen for him not to change. And you put them side by side, and they look completely different now. So the one that was copied, all the blues have faded completely. So it's like he used ultramarine in the original one. And then in the copy, well, I'm not really sure, but you know, they're totally different paintings. So I'm not sure if your question is about the way the paintings change in appearance, but even using, you know, traditional pigments like that, what would the blue have been? I mean, it's gone. So there's that. There's also, with Rika's research, you know, coming up to date, as chemical pigments came in much later, from, you know, 1750s, 1800 onwards, they didn't know about light fastness or anything like that. And so particularly when the late you know, synthetic dyes and things started coming in, they faded pretty fast, as Van Gogh, you know, we found out with Van Gogh's paintings. You take one out of a frame and along the rebate it's still bright pink, whereas where the painting itself is, the sunlight's completely bleached it.
Sure.
And in galleries nowadays, you know, we have to make sure that we take that into account when the paintings are displayed. So we need really to use Rika's techniques to be able to establish, when we have a painting, which of those pigments are vulnerable, and if they are, whether to light them, you know, sympathetically or differently to preserve them. That was my thoughts anyway.
Yeah, and maybe to add also, as conservators, so our role is to document it. We don't want to establish the original state. So what we want to preserve the state that we have now, because also the aging is part of something that has to be preserved if it's not harming the painting itself. So we use, for example, if we use photographic equipment, we calibrate it to get the colors as naturalistic as they are nowadays. Or if we do hyperspectral imaging, also in order to understand differences between different lakes used, for example, you also calibrate in order to get a good spectrum, absorbance spectrum of the visible range. But it's more a documentation tool, or learning, as Simon pointed out correctly, learning about, are there any vulnerable areas that we need to consider, but we do not go back to the state. There is some projects doing that. They try to recover original paintings, especially on Van Gogh. I think there is this depiction of his bedroom, which completely changed. I'm not super familiar with this case, but basically they try to reproduce the original original occurrence of the painting, but we do not reinstall that. So we preserve what is there.
Thank you.
So I think Raphael's got an interesting question in the rather long question in the chat, but I think it's a little bit off in a different area to what we're talking about today. So maybe, but perhaps you could look at that, and if you've got any thoughts, perhaps we can put it on the in the comments on the YouTube video or something like that. But there's another question just came in, or a couple of questions just came in. So the first one was what from Lisa, what is your recommendation for preparation, oil paints and binding agents in 2025 that are light resilient? As conservators, I guess.
Yeah, it's a question you can't really answer. I think it always depends on the combination you're using. Like some pigments match with some binders and others don't. I think it's, yeah. Don't know what your thoughts were, Sam. Sorry, I interrupted you.
No, thank you for interrupting me. I didn't have anything sensible to add. Look at the tubes, I suppose. Check the light fastness. And I think generally they're pretty good, aren't they? What's being produced. Don't worry about it too much, I think.
Would it be fair to say, like, it's a vast area, but there's a lot of information out there, and probably if a good place to look would be, there are forums like the Mitra forum, which I haven't looked at for a little while, but that I think was the University of Delaware had a forum that had a lot of questions from the public and a lot of information on there. But yes, I think the answer is a vast. Basically there's a huge amount of information about.
Yeah, I mean, if you're talking about mixing your own paints, I mean, you can find pigments and then grind it up in oil and that sort of thing. People are very keen to do that sort of thing. It's difficult to disperse the pigments really well. I worked on a painting by John Russell, who, Australian impressionist, who was writing to Tom Roberts how he mixed his own paint up because they were looking for purity and really good light fastness and brilliance and all that sort of stuff. It was that impressionist time when the new chemical pigments were being brought in and produced lots of new opportunities to really intensify the saturation of the colours. And it was a problem because he couldn't cover the pigments properly in oil, but because it wasn't done on rollers, he was just doing it sort of on the palette, which meant that the pigments were exposed to the air and to each other. And so you get the pigments reacting together when you look at John Russell paintings like emerald green, for example, and cadmium yellow react together. If they're well bound in oil, then they're chemically safe. But if you're doing it yourself on the palette, then you find that they can be exposed to each other's chemistry, and the result is they kind of react together and fall apart. So I'm sort of in favor of letting the professionals look after that.
Great. All right, there's a question here from someone. How difficult is it, I guess, to carry out chemical elemental mapping using handheld XRF and not the higher tech XRF like Bruker M6 used?
I think that's a question for me. So generally, handheld XRF, for everyone who doesn't know it, it's like a gun that you have direct contact to your sample, and then you can acquire a spectral, what Rika also used as a technique. Generally, you don't really necessarily need to have contact. You can also operate it with a certain distance. I know that one of our researcher from our audience today has done exactly that. So he took a handheld gun and he set it onto a motorized stage, connected it to that, wrote a tool how to tow movement or tow align movement and measurement, and created maps from that. So it's possible if you have some technical knowledge. I think he published a paper. His name is Anastasios Asvestas, and it's called something with real-time. Let me check. Real-time elemental mapping or something like this. Maybe you can comment on that, Tassos. I know that you are here today, so it's possible. You can do it. Of course, you will contribute. So you have a larger beam. You will not have such a high resolution. You have to understand that you don't see so many application traces in such a highly resolved way. So sometimes they are hard to access with larger beams, but it's possible, of course.
And with the handheld XRF, I always found, if I've got the question right, that you get kind of a whole list of elements that are there, but you don't actually know what's connected to what. So you have to kind of look at the color in that area, and often it's layered anyway, and they mix together. So it's very hard to kind of know, is that lead attached to the tin, or is it carbonate, or what? Or what's the sulfur attached to, and the barium? They could be in multiple different pigments with completely different colors. So when the mapping came along, that was so useful, because you can then really just map it against the color that you're seeing, the passage of paint. You know, it replicates the painting itself. So you can see that if there's, you know, two elements that are both in a green, you know, like, you know, copper and something, then, you know, that those elements go together, because both elements will be mapped in identical areas. You see what I mean?
Oh. Okay, and the link to that study has just been posted in the chat down the bottom there. So, from Tassos, that's great. I must ask, Rika, is your study published, or is it about to be published?
Yes, it's published, and you can see it on the website of the University of Amsterdam. So my
Okay.
whole PhD is online, also with links to the data in it. So you can, everything's open access.
Oh, good. Great to know. Fantastic. All right. I think we've got time for maybe just one more. Sabine is asking, how about non-permanent pigments such as smalt, which migrated? Can you see that on paintings now, and how? Any?
I've got a, sorry, go on, Marieke.
You can also go.
Well, I've got a painting. There's a painting work in the Art Gallery in New South Wales on the wall. It's by Van Bielet, and she's got an orange top and a completely brown skirt. But the skirt was originally, or dress was originally bright blue, and it was smalt. And of course, it was a complementary of the orange, and that was the point. And I'm really keen to do a Photoshop thing and recreate it as it's supposed to be, so people can look at it on their iPads or something. But yeah, that's completely faded, and I can't remember what the question was now, but yeah, it's to do with the cobalt ions bleeding out of the glass, isn't it? And I don't think it's a reversible thing.
No, it's not. So nowadays, this is also one of the things that I saw in the Rembrandt that I presented. He used smalt also in order to modify the properties of his paint to make it more stiff and dry more quickly. So he would add it to a lot of different colors, including a lot of the darker background areas. And for the Rembrandt painting in this case, for example, you see that it's the colors have lost their depth. They are more, let's say, grayish and don't give such a field of depth that you would usually assume, and losing some of the details from the painting truly because the smalt degraded. So it's a quite common thing that can occur, changing the color, but it's not something that we can revive.
Okay then. Look, I'll just try to squeeze one more in. There's one from Raphael again. So perhaps if we can have a quick response. I'll just read it out quickly. The recent study, Pompeian Pigments, a glimpse into ancient Roman colouring materials, has revealed evidence of sophisticated pigment mixing applied directly to the pictorial surface, suggesting an advanced understanding of tonal modulation by Roman artists between 300 BC and 79 AD. Do you know if there is any literature predating this Pompeian example, I presume on art predating that example, that indicates artists deliberately blending pigments in situ to achieve specific chromatic or tonal effects?
I'm sure there's an expert out there who could know exactly what you're talking about. It's not me, but to me, when I look at some of those paintings from back then, I'm just stunned. I used to have this idea that paintings didn't have perspective or anything to start with, and then we got better and better at all that. But actually, when you look at them, they're just as good as anything we do now. You know, they knew exactly what they were doing, and you know, could produce stuff completely, you know, as sophisticated as anything.
Yeah. So you already have Pliny the Elder, his manuscript. Naturalis Historia, documenting how artists painted at that time, basically already using also underdrawings. So he has this really nice phrase where he says some of the underdrawings, so the compositional drawings on the pictorial ground before painting, are so elaborate that it's better that would have been better if the artist would have not finished it. So it's we have an evolution in the way paintings are being created, but already at that state, you have a certain structuring. You create your ground, and then you do an underdrawing, and then you paint. And yes, you also have pigment mixtures at that time. I'm not aware directly of a study, but I think if you Google that, you should be finding something. Yeah, or check Pliny. It's including a lot of interesting information on general art technology, also apart from paintings.
And in terms of technology, did they have? There was wax, a wax and caustic sort of method, wasn't there? Which I've sort of tried and makes it very hard to mix. They wouldn't have had linseed or drying oil, I don't think, as a technology, which really made it easy to blend colors.
Yeah, and caustic, I'm not so sure if they also used egg, but I'm not an expert of this era.
No, well, thank you very much for answering, and Raphael sends his thanks. So thank you all our wonderful speakers. Thank you. You made this very easy to put together, and you've all done a fantastic job and really interesting presentation. So just before we finish, I should mention that this has just been one of many celebrations of International Colour Day 2025 around the world. Our own Western Australian division is having an in-person International Colour Day event at the Peppermint Grove Library in Perth. So if you happen to be in Perth, you could still join that if you email the president of the CSA. There are also a number of events over this next 24 hours, I think, and I'm not sure if you can still register for any of them, but you can find them on our Facebook, Instagram, or on the CSA website under news. So one of them is the Slade School of Art Colour and Poetry event, which is starting right now. So I'm about to head over to that. So once again, thanks, Mariah João, for the introduction, and to all our speakers, and thanks to everyone who came along. We'll see you next time.
Cheers.
Bye.
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 Sure.